This board is about the electricity section of our summer school. These are the questions that the board will include. For the first question, 22.6, you'll have to know that the charge of an electron is negative 1.6 times 10 to the negative 19 coulombs. You will have to use standard form here because otherwise you won't be able to work through the questions. You'll have too many zeros to write and you'll lose track of your decimal place. So if you're not sure how to use standard form, it's worth picking up and looking at that now. In the second part of the question, you'll have to know that the current flowing through a component is equal to the charge that flows through it divided by the time it takes for that charge to flow. If your current is in amperes, then the charge must be in coulombs and the time must be in seconds. In 22.16, a new unit of charge is introduced called the amp hour. And an amp hour is an ampere multiplied by an hour. Remember that an hour is 3,600 seconds. This is still a unit of charge because ampere is current, which is charge divided by time. So if you multiply it by time, the times cancel and what you're left with is a charge. But ampere is a unit different to coulombs. So essentially what this question is asking you to do is to convert amp hours into coulombs. For 23.8, there are two circuit rules that you have to know. They're called Kirchhoff's laws. Kirchhoff's first law is that current is conserved, and that's because charge is conserved. Basically what this means is if you have a junction, the total charge per second flowing into that junction is equal to the total charge per second flowing out of this junction. And so you can see from my formula here, current in, I1, is equal to the current out, I2 plus I3. A consequence of Kirchhoff's first law is that two components in series will have the same current flowing through them. If we have two components, for example two resistors in series, and the first one has 3 amperes flowing through it, so does the second. Kirchhoff's second law is about conservation of energy, and what it tells us is that within a loop in a circuit, the voltage gained by a power supply is equal to the voltage lost across any components, and that the voltage is shared between those components when they are in series. And a key thing with Kirchhoff's second law is we treat each loop separately. In this circuit there's one loop. We pick up V1 volts, we drop off V2 volts and V3 volts. And that's where we get that equation there. If our circuit was extended with another resistor in parallel with V2, then we use the same rules. In the first loop we pick up V1, we drop off V2 and then we drop off V3. But in the second loop, we pick up V1, then we drop off V4, and then we drop off V2. And so those are the two possible loops in our circuit. A consequence of this is that two components in parallel will have the same voltage across them. This is such an important skill and such a difficult area for students to master that I've included two questions where you have to analyse circuits, 23.8 and also 23.9. 24.6 is using an equation related to Ohm's law. What is Ohm's law? V equals I R, and rearranging that equation, where R is the resistance in ohms, V is the voltage or potential difference in volts, and I is the current in amperes. The tricky thing here is that you'll have questions with milliamps, and milliamps are 10 to the negative 3 amperes, and maybe even kilo ohms, and kilo ohms is 10 to the 3 ohms, or some combination. So you may have to look up what micro, milli, kilo, mega, but also nano, pico, giga and tera. And I've written these in a very silly order. There we are, that's better. And you will need to know all these off by heart for your GCSE. You have to memorise them. Tera, giga, mega, kilo, milli, micro, nano and pico. And those are the multipliers. 10 to the 12, 10 to the 9, 10 to the 6, 10 to the 3, 10 to the negative 3, 10 to the negative 6, 10 to the negative 9 and 10 to the negative 12. 25.1 uses the same equation as 24.6, except you'll have to read numbers off a graph, but otherwise it's the same sort of thing. 26.9 makes use of the equation power equals voltage multiplied by current. And here power is measured in watts, voltage in ampere, voltage in volts, and current in amperes. You will also have to use the equation that relates current to charge that you did very early on in this sheet. I think that was the first question in this sheet. And question 27.4 uses the equation you can see on the top of the screen, V equals IR, and the equation you can see further down the screen, P equals VI, and combines those two equations to get a new equation, P equals I squared R. Basically, if you substitute the equation for 24.6 into the equation for 26.9, it will equal the equation for 27.4. And then you substitute your numbers in. Now please don't forget, when attempting questions, if you need a bit more help, then you can get it. If you choose, for example, 22.16 and you're finding this difficult, click on the Hints tab and then click Notes on Charge and Current, and it'll take you to a page that gives you a bit of background information about this. There might also be some examples you can follow before you try the question yourself. So you're not alone, there's plenty of help out there. And if you click on the Hint 2, most of these have a little video that will also explain to you how to answer these questions. So work through that board of questions yourself, see how you get on, and then on Saturday morning at 10 o'clock we will go through any problems that you're having. Please make sure you're logged on to Isaac Physics when you try the questions, or your progress will not be saved. I'll see you next week.